All right, good morning. So welcome back to pre-calculus. We're going to take a crack here at 2.5, number 5 here. We have an area covered by a certain population of bacteria is increasing to a continuous exponential growth. So suppose we have an initial culture with an area of 81.1 meters squared, okay, and observed doubling time of 11 minutes, okay? So let T be the time in minutes, let Y be the area, and what we're going to do is we're going to see if we can't come up with a formula here, and they say do not use approximations. Okay, so what we're going to do is here we're going to should have dealt with this beforehand. Actually, let's do draw a square page. Do that. So let's see here. We have doubling time of 11 minutes. So we have doubling time of 11 minutes. So doubling 11 minutes. So T is going to be in minutes. Okay, and then we have doubling time rather than half-life. Okay, so it's a little bit different. So we're going to go off and say, well, we have a population equal to an initial population, e to the k t. Okay, that's the model they want us to use. See, they even give us like on the formula, y equals something e to the something t. All right, so let's see what we have here. We want whatever we start with, and we have an initial area of, let's say here, it said 8.1. Okay, so our initial area here is 8.1. And then we just going to double it. So it doesn't really matter what the initial one they gave us. We're just going to say 2 times 8.1 here. Okay. We have e to the k t. How much time did it take for this for that happen? Okay, they said this doubling time happened in 11 minutes. We have 11 up here. So t is 11. Okay, so we're just going to pretty much here solve for k. We're solving for k. So the 8.1s are going to cancel by that on both sides. So we have 2 is equal to e to the 11k. We're going to do, we have to get we have an unknown in the exponent position. How do we get it down? Take a natural log of both sides. So we have natural log of 2 equals natural log e to the 11k. This business here, this will pop down in front. So we have 11k times natural log of e is equal to the natural log of 2. That's 1. So k is equal to a natural log of 2 over 11. When I did this problem before, I usually changed half-life into natural log of a half. I usually change this into negative natural log 2. It marked me wrong. If you did not put natural log of 0.5, it was very unhappy. Okay, so we're just going to leave this as is. Okay, so my k is equal to natural log of 2 divided by 11. That's just what we're going to enter in here. I'm not going to promise us that's our best answer, but we'll go ahead and give it a shot. Okay, let's go ahead and do that. So going back and looking at, we have 81.8.1. So y equals our initial amount, 8.1 here, 8.1. And this is going to be e to the, don't approximate, they want 1/11. They want natural log of 2. So I'm going to write in here, right? We have this guy right here. So we have natural log of 2, but not 22, just 2. Okay. And say divided by 11. That should do it. Okay, that should be natural log of 2. I don't like that. That looks like it's natural log of 2/11. So I don't like that. So what we're going to do is we're going to go back here, say 1/11. That looks a lot better. Okay, that's how I want to write this. Okay, and then all we're going to do here is we're going to type in t for 17 to get the rest of this thing and see if that works. So I'll show you that. So go ahead and clear. Okay, so we have 8.1 times second function ln. Okay, that'll bring us our e. We're going to have 1/11. Okay, actually, we could you know, since we know that 17 minutes, right? We can say 17 over 11 here, right? That's so let's go this way. Let's say 17 divided by 11. Okay, and then times, okay, natural log 2. So ln 2. All right, and then we'll pop that in. That looks about good. Okay, remember the rules of exponents, right? We have an exponent raised to an exponent, we multiply them together. That's why we could do this. That's why when this turns into a 17, we have 17 over 11. Natural log 2. 17 over 11, natural log 2. And that should do it. So let's hit enter. We have 23.6. And they just want it to the nearest tenth. So we're just going to say 23.6. These are extremely sensitive to round off errors. So if you're in face-to-face class, I usually tell you if you want to take a break at figuring out the K, I would say 4 significant digits. Write that down. But there we're going to go with no approximations. Okay. So we'll say 23.6 here. They are very sensitive to round off. Round off. You know, a lot of students have had in the past round off to 2 decimal places. They are way off. They're like, I can't get it to work out. Like, yeah, because they're expecting not to be bad. Check. I'm not going to guarantee it's right. Oh, how about that? It was. Okay, so they like that. So I'm going to go ahead and put it here. That way they stay short, and we'll be back in the next one. Okay, so thank you for coming, and we'll see you in the next video.